If I ask you to repeat a word 5 times, then you will be able to do so because you can count. We don't know any animals who can count the number of calls or the sounds that they produce. But in a recent study, scientists have found that crows can also count the number of calls that they make. Crows are intelligent birds that have the ability to recognize faces and even use objects as tools. They can also be trained to produce their characteristic cow cow when asked to. In a recent study, scientists used these trained crows. They showed a number between 1 to 4 on a screen. That will be the number of times that the scientists want the crows to make its calls, and then the crow was taught to touch a button on a screen. If the number of calls they made matched the number that was shown to them, then they will receive a reward of seeds or worms. The scientists found that the crows learned to produce the same number of calls that was shown to them. Their first call was different for different numbers, which shows that they can count and even plan the number of calls that they are going to make in advance. Although this counting by crows does not mean that they can understand numbers like we do, but studying this behavior can help us to understand how the human brain evolved to understand numbers. This understanding can help individuals who have difficulty in numerical calculations, a condition which is known as dyscalculia. What could be the next big advancement in wearable technology after wristbands and rings that help you monitor your health? It is biosensors that can be directly printed on your skin, can be repaired and even washed away. There already exist biosensors like that, but these interfere with the normal functioning of the skin. Taking inspiration from spider silk, researchers at Cambridge University have now created biosensors that can be spun into thin fibers. These fibers are 50 times smaller than human hair and can be printed directly on a surface like your fingertip or a flower petal. They can be printed with such precision that they can match the shape and pattern of a fingerprint. These biosensors are also inexpensive and eco-friendly. Another advantage is that these biosensor fibers does not interfere with the functioning of the skin, and the user is not even aware of their presence. They can be used to monitor our body and also the environment. They have the potential to take virtual reality to the next level. These biosensors are in the process to be commercialized, and we hope to see them soon in the market for use. Remember the static charge that can make a balloon stick to your hair or give you tiny shocks when you touch a metallic surface. That same static electricity helps caterpillars protect themselves from predator wasps by detecting the frequency of their wing movements. Scientists have known that insects build up static charges on their bodies, which can push or pull other charged objects in their environment. Researchers at the University of Bristol wanted to see if the static electric field from a wasp, which can move caterpillar hairs, could be detected by the caterpillar and alert them to the wasp's presence. They measured the static charge of both the caterpillars and the wasps. Then they calculated and measured the electric field and the movement of caterpillar hairs in response to the wasp's static electric field. They found that the movement of a wasp's wings could indeed move the caterpillar hairs, thus making the caterpillars aware of the wasp's presence. This study highlights that insects like caterpillars can be affected by the electric fields created by human-made electronic equipment. Since identifying predators is crucial for the survival of insects, we are interfering with their lives in yet another way.